Hello, everyone. We are here today with some of our ARM friends and collaborators to talk about how SUSE and ARM can work together in the open source communities to aim at the same goals, enabling hardware and enabling people with software and hardware. So we're here today with Andrew, Guillaume, and Philippe, and I'm very thrilled to have them today to talk about this topic. So, Andrew, maybe would you like to start introducing yourself?
Sure. Hi, everyone. Andrew Wafaa. I'm Director of Open Source at ARM. I focus primarily on upstream open source projects. I also drive our open source office, which is looking at open source adoption and implementation, both internally and externally.
Thank you, Andrew. Philippe, would you mind to introduce yourself, please?
Yes, hi, I'm Philippe Robin. So I am Director of Open Source, part of the infrastructure group in ARM, and essentially working with open source communities and companies like SUSE in bringing product and solutions onto ARM platforms.
Thank you, Philippe. And Guillaume, last but not least.
Hi, everybody. So I'm Guillaume Gardet. I'm engineer at ARM. I'm part of the distro team dedicated to SUSE and OpenSUSE.
Thank you, Guillaume. So I would like to start with a very high-level question, and maybe Philippe, you could help me with that. ARM has gone through significant changes in the past few years, and I wonder, could you give us an update on where the company is today?
Yeah, the company's changed quite a lot. I joined the company in 1999, and ARM is actually going to be about 30 years old this November. And it's really gone through a lot of changes since its formation with Acorn, Apple, and VLSI. So still business is primarily the same. It's focused on the licensing technology and building on the partnership culture, which SUSE is part of, really. Today, as I'm about over 1,700 licenses, and the number is really growing about 100 per year. And with about 160 billion ARM chips, which have been shipped so far. So the company first IPO'd actually in 1998 and went through quite a number of changes and being acquired by SoftBank in 2016. But in size, we're still moderate-sized company, still about 7,000 employees, split in about 50 offices in 20 countries. So it's still not a very large company. And in terms of structure, it's now structured in addition to the main functions. It's got two large groups. So the IP groups, the product group, which is designing technology and licensing IP to partners, which is CPUs, GPUs, and other IP we develop. And the IoT, Internet of Things Services Group, which is looking at solutions to securely connect and manage data services. So that's really the shape of the company today.
Thank you, Philippe. And I just have a sort of follow-up question to that. So obviously, ARM has been known for a long time for its mobile and embedded business. But I really wonder, like in recent years, ARM has been involved a lot also with the infrastructure and server platforms. So could you explain me a little bit basically how ARM works in enabling this broader software ecosystem? Because it's really like going from the embedded device to the server, it's a huge set of devices. So how does that work for you?
Yeah, it's come a long way, actually. When Linux took up more mind share with companies and developers, that was essentially driven by the consumer space in Japan, actually, particularly. But a lot of the companies who were building solutions were really building solutions on specific solutions for their platform and optimizing the software stack as much as they could. So the solutions which actually were primarily used in these kind of configurations are solutions like Yocto, Open Embedded, and the likes, which allows them to build all those platforms. But that ended up with an ecosystem which had some level of fragmentations and making it hard to run standard Linux distributions and software like SUSE and similar. And as we are evolving and growing into the cloud and infrastructure space, we really had to work with partners and software companies in bringing more level of standardizations with initiatives like the server-based system architecture, SBSA, which really was looking at having a base level of features which software companies can rely on, and OEMs and silicon partners build. So the software just runs out of the box. So it's a number of those initiatives for boot, for server-based architecture. And we also complemented that with server-ready compliance programs with test suite to actually validate that compliance. So it's a lot of work which has gone into that, and actually taking a lot of input from companies like SUSE to really make sure we meet all the requirements they need to run their software. And all of that is still evolving today as we are broadening into Edge and other categories as well. And that really has enabled a number of initiatives, particularly with SUSE, the Catalyst UK initiatives for initially targeting exascale computer with HP, and that was first inroads of ARM into the HPC space. And more, following that, also the enablement of SUSE on platform like Raspberry Pi and leading to new product lines becoming available on ARM, like self-storage solutions, which you guys have worked on with companies like Embedded, actually is a good step. And in terms of certifications, you had certification for SUSE Linux, SUSE Enterprise Linux, and Ceph, for example, with the Titan platform with Varlese. So all of that is really to enable your solutions to run smoother onto the mix of platforms partners are developing. And more recently, we see SUSE images available on Graviton, AWS instances, and the like. So really, it's leading to it's building on all those years of joint work and standardization.
And this is really what it is about: collaboration to ensure that the ecosystem can really be enabled. And this really leads me to another question, and I guess this is for Andy now. And Andrew, we know each other for quite some time, and we've been working together quite a lot. I wonder if you could explain me how does ARM, and as Philippe said, an IP company, really work with open source projects? So what is at the core? How these things really happen in real life?
Yeah, sure. So the first step for ARM is to do some core enablement work. So primarily that's within the likes of the Linux kernel and tool chains, be the GNU tool chain or the LLVM tool chain. So we work very closely with those communities to ensure that those foundational building blocks, the core CPU implementation, etc., are upstreamed and available within those foundational projects. If you don't have a kernel, you're not going to be able to boot a system. And same goes for the tool chain. You need that tool chain to be able to actually build everything and get it to run. So they're kind of the first steps. Get the kernel and tool chain up and running. And then we start looking at, okay, let's look at additional foundational libraries, specific languages and runtimes, ensuring that those are all enabled. And we work very closely with the upstream, and that's part of my role, is to help facilitate those discussions between ARM engineers and the respective projects, looking at integrating CI/CD, looking at enabling and pointing the right people to the right documentation, as an example, that's all public there. and so that's how we work slowly up the stack until we get to user space and other aspects of a system that you wouldn't necessarily think about. For instance, to get an ARM-based laptop working, whether it be a Chromebook or a Windows and ARM machine, you're going to need GNOME and KDE, etc. there. So that's very high up the stack in comparison to what you would need to get working for AWS Graviton, as an example. And so quite often those client devices tend to be the later platforms that get enabled because we have to work our way up there. But we work very heavily with key foundations like Linux Foundation. Obviously, there's the Apache Foundation, which we're involved with quite heavily from a big data perspective. And we're in a myriad of different organizations and projects where we have maintainers and contributors across the board. So yeah.
Great. So now I wonder if we look at SUSE and ARM, how does this enablement really work? How does these enablement activities really impact SUSE developers? And is there an opportunity for customers and partners to participate into this enablement?
Right. So, as with everything, it starts with the upstream. So if things are working in the upstream, it's much easier for distributions, whether it be SUSE or OpenSUSE, to consume and integrate in the wider world. And so the enablement work that we have done within the upstream projects allows people to then go to tooling like the Open Build service and start building packages for ARM and validating that, okay, this is the package set for SLE or OpenSUSE, flick a switch, work with the OBS developers to help them ensure that OBS does support ARM as much as x86. And at the end of the day, the thing that we're looking for here is parity with the other architectures. We don't want, well, we would like to see ARM as a top tier architecture across the board. So just as you would expect x86 to just work, the same goes for ARM. So looking at ways that we can facilitate that within the tooling, whether it be OBS, whether it be OpenQA, and getting everything validated through that and get that working. And so, working with the distributions led to identifying a gap that we had within the OpenSUSE community. We had no release manager for ARM on OpenSUSE as a community, and the ARM community within OpenSUSE was quite vibrant, and there were a few people that were very active, and so it led to identifying Guillaume as a potential candidate for release management. Working with the existing release managers for Tumbleweed and Leap, we came to an arrangement and an agreement that Guillaume would be able to take a task on. And it also led to Guillaume being able to join ARM and actually helping the SUSE developers on key specifics, ensuring that from a SLE perspective, all the technical requirements were filed in Jira, following up with bug reports and Bugzilla, working on those, working with our partners to ensure that their needs were met when it comes to aspects of the SUSE interaction, and working closely with the ARM team at SUSE. And obviously, a key aspect was at events, whether it be SUSECon, whether it be OpenSUSEConf, or any of the other community events, making sure that ARM is present, represented, have our booth, do presentations and such like, and actually be available for interactions and working with people. And for customers and partners to participate, we're doing as much of it as we can in the open. And so it's just another architecture as part of the project. So there's nothing stopping people from enabling ARM within their projects, within their software. And if there are problems, we're here to help.
Thank you, Andy. That's great. On that note, I know that we have collaborated quite a lot in different various upstream projects, ranging from the networking projects to the kernel and to obviously the OpenSUSE and SUSE distributions. So our work relationship really goes back quite some time. But Guillaume, now with you, like as Andy said, you're looking after the release management for ARM, and yourself, together with myself, we've been working quite a lot recently on many different aspects of packaging and offering software via our distribution. So I would really like to ask you, what is your really daily job? How does it look like? And this is not to tell me, but really to inspire others that are really curious about this open source world, but they maybe do not really understand all the caveats that are around it. So if you could just dedicate some time to explain what you really do during your day, if that can be said.
Yeah. So my daily job is to be the release manager of OpenSUSE Tumbleweed and OpenSUSE Leap for ARM, because other architectures are managed by other people, but I work closely with them as well. Why ARM focused on OpenSUSE is very simple. It's because it's the upstream for SUSE. So if we work on OpenSUSE, it will also benefit on SUSE. So it's very important to keep OpenSUSE in good shapes. It covers OBS because you need to build packages in the first place, and once you have the packages built, you need to test them to ensure it's working properly. So that's why we also work on OpenQA. And if all is fine in OBS and then in OpenQA, we can release it publicly. So that's really the main part. So the first, as I told you, it's making sure latest SUSE and OpenSUSE software builds properly on ARM in OBS. Then once the whole project finished to build, it's automatically pushed to OpenQA, where we run quite a huge number of tests for ARM. For example, for Tumbleweed, we have about 135 tests. And for Leap, we are at about 19.4 tests. So it's quite extensive. Sometimes we also do manual tests, but OpenQA is automated, so it's really, really simple to run them and to have a good coverage. With that, so OpenQA and manual testing, we need to cover a wide range of hardware because we have embedded style hardware, such as the Raspberry Pi, up to servers. So it's not always easy to test all the software on all hardware. We also need to test some virtual machine images, some containers. So OpenQA is very handy for that and very good. I can give you a few examples. Last year, I worked on cubic microRes for ARM, and it has been demoed at SUSECon 19 in Nashville. We also work together, Marco, on AI, ML software and containers, images. So we have TensorFlow 1 and 2, Caffe, ARMNN, building and tested and working fine on ARM.
And we had the pleasure to present as well at SUSECon Digital this year together.
Yes, that's right. And more recently, I work on Leap MicroRes, which is still in development, but I'm happy to say you that x86 is supported at the same level as ARM.
That's very nice to hear.
I work also on improving tools, existing tools, to cover new use cases for ARM. For example, now OpenQA is able to test real hardware such as a Raspberry Pi. And I'll also ensure that latest ARM technology is enabled from upstream and works as expected with OpenSUSE and SUSE, and keeping compatibility with existing hardware. So, for example, we have some optimized libraries and software in SUSE and OpenSUSE, such as ARM Compute Library, which is used by ARMNN to be very efficient on ARM hardware. Very recently, early in June, with a switch to GCC 10 in Tumbleweed, we enable LSE Atomics instruction for Tumbleweed. So now ARMv 8.1 LSE enabled hardware are taking advantage of those new instructions and get a boost in performances. And it does not break existing ARMv 8.0 hardware, and there is no performance impact on those hardware. So that's very cool. And also we need to enable new platforms regularly, and still making sure all is running fine on those new platforms. So now you should have a good overview of my daily job.
Yes, I do. Yes, I do. I wonder, like, how the latest tasks that you have told me, like, for example, the enablement of a specific hardware instruction set, how does that really indirectly relate to working with the OpenSUSE SUSE community? What that actually needs to be done in that perspective?
In SUSE and OpenSUSE, we have an upstream first policy. So if you want to get something in SUSE or OpenSUSE, you need to have it in upstream first. If it's not yet integrated, you at least must send patches, and maybe you have some review after all, but really the upstream first policy is very important. With that, we make sure that we not duplicate efforts across distribution, and also if you want to update packages later, you will need to rebase your patches, and it's time consuming. Whereas if already upstream, you do the job once, and then you're fine. So we need to work with upstream, as Andrew said before, and I work with very various upstream projects to fix issues. I also help ARM partners to enable their software on ARM based on SUSE or OpenSUSE. I can give you the example of GitLab. GitLab was only for x86, And now you can build GitLab for ARM64. And you should have rather soon official packages for ARM as well.
And just to clarify, that's for GitLab Enterprise. The open source aspect of GitLab has been available for a while.
Yeah.
And nowadays, most people do care about AR64 support, and they do not push things broken on ARM, because in the past it was just well, it builds and works on x86. Just push it, and they don't care about ARM. And it's changing, and most people now are really interested in ARM support as well. So I think ARM is reaching its first-class citizen in SUSE and OpenSUSE, but also outside the project and more globally.
Yes, and I can definitely second that, and I would like to take a minute to really tell how great it is to work together. Like the project that we've been involved in together, and recently the artificial intelligence initiative that we have been looking at in the OpenSUSE community. That has been really a pleasure, and as you said, it was really ensuring that it wasn't just x86, the target platform, but that the AR64 was as well a first-class citizen in there. And I truly believe that collaborating together with the power offered by the Open Build service, which really enables all the different platforms just with a click, that really helps developers to ensure that different platforms are the target for specific projects. And again, as you said, I would really like to thank you as well for the OpenQA work that has been carried over for the machine learning frameworks, because really you initiated that, and I am, very humble saying we actually had tests for machine learning frameworks on OpenQA for ARM before having it for x86, which was great. So, and again, this is all thanks to really some great collaboration and some friendship that is built across these communities, the open source communities. And in fact, I would really like to point out that we actually met at a conference, right? We never met before, and our collaboration started from there. And this is really what should inspire people for the open source world, which is, it's full of great people that become very much friends before and then colleagues later. So that's just a great thing to tell. It's a great story. And with that, I would really like to thank you guys for the time today. I know that you are all very busy, so thank you for this time. And I really look forward to meeting in person soon.
Hopefully, yeah.
Thank you, Marco, and thank you to all the SUSE community as well.
Indeed.
Thank you.
Thanks a lot.
Thank you.
Thank you, folks.